Hello guys, let me introduce myself. My name is Rimawanti Fauzyah and RP57 from PANS AIPs, and we met in the database 1 review of database 1 with my lecturer Mr. Rengga Asmara, ESCOM OCA. Now we will go to the lesson. Objective. We have 4 objectives here to this lesson. First, understand database management system and its main component. Second, understand AR model and able to use it for the beginning of a database. So for the beginning of database, we have to make an AR model to design our database. Third is to understand SQL and anything contained in SQL language. And the fourth is understand concept of normalization and be able to realize. Now we go to the lesson. Main subject. So we have first introduction. Second is like what I say, ER model. And then relational model and the SQL, structured query language. Okay, let's go to the lesson. Oh yes, there are 5 subject. Yes, there is normalization. Next, introduction. So in the introduction subject, we will know what is database and what is DBMS and what for database. Next, so what is database? Database is a collection of data which can be described as the activity of one or more related organization. So database is a data with many datas and it's collect into one. It called database. For example, a university database contains information about entity. Entity, the example is student, faculty, lecturer, books, and etc. So entity is an object. We can call it an object, an independent object, but it can be relation with another object. And the second is relation between entity, such as taking course conducted by student. It's the example where student of course have to take course from the faculty, and the second example is faculty staff and use of the lecture room. So students have relation with faculty staff or maybe lecturer, and yes, with people in the campus area, and use of the lecturer room, so class, laboratory room, and so many others. In theory, so it's only in theory, relation consists of one-to-one relation, one-to-many relation, and many-to-many. Yes, of course. From my lecture, I got the reason that one-to-one is only in theory. So in the reality, we may not found the one-to-one relationship. It's only one-to-many and many-to-many. Many-to-many itself, it contains one-to-many, and many-to-one. So the union of is of it is called many-to-many. So the in the reality, relation that exists is only one-to-many. Next, what is DBMS? Now, just before we know that what is database, and now what is the DBMS? DBMS are the acronym of Database Management System, is software designed to assist in maintenance and utilities collection of large amounts of data. So DBMS is usually used for large collection of data. Example of DBMS: Microsoft Access is present by Windows, MySQL, SQLite, Oracle, etc. Microsoft Access is only for Windows only, of course, and MySQL now is one of part of the Oracle that we know learning, and SQLite usually used for browser, and yes, many others. So what is the function of DBMS? Just like the definition of DBMS, the purpose of teaching the course database is to provide an introduction. So we provide an introduction to database management system with an emphasis on how to organize the information in a DBMS. And now the second subject is ER model. So what is ERG? How is ERG? And what for ERG? We will now discuss. Next. So what is AR model? AR model is a drawing of real world that describe with object and their relationship. AR models used to develop the initial design of the database. It's the function, it's the purpose, and it's the definition of AR model. To create a database, we have to create ER model before. Yes, of course. Why? Why? Next. Why and what for ER model? ER model provides a useful concept that can change the description informal than what is desired by the user, becomes more detailed and precise. So ER model is very useful for us to understand what truly user wants, and we draw the user needs in a drawing using AR model. It will be detailed and precise, and we can we can uh we can realize the AR model to the our DBMS. How AR model look like? Nah, yes, I have an example of AR model. One entity, attribute, association of entity. This is the SSN or serial number is an association of entity that always have key. The underline, it means that it always key. And employees. Employees is entity. An entity is real object. Lot. Lot, which described in oval, is an attribute. How a model look like? It's still the continualism, and two, we have relation and association of relation. This is one example, a relation between employees entity and departments entity. Yes, we can see it. It's the database of employees, and it's the database of department. I mean it's tabel employees and tabel departments, and we can use the relation employees works in, because it's many to many, so it of course will make a new attribute in between this relation. So if it's relation, what is association of relation? Yes, of course, it's association among many entities. So we have many entities that are related to each other, or we simply call it relation of relation. And third, additional feature for AR model. Key constraint. Example, a data must not null. So the data is may not not null. And the two is participation constraints. Total participation. Example, every department have a manager, so it's called total participation, that two of entity complete each other. And second is partial participation. The example is there is departments who do not have manager. It's partial participation. So entity have relation with manager, but there are no manager in this department. And three, weak entity is an entity that value is 1 between 1 and n relation. So if we have one too many relation, entity that value is 1 is called weak entity. Note, never use partial participation and weak entity to create an AR model, because it will confuse us. So, and the fourth, hierarchy class is attribute that can be derived. Example, if we declare A is a P, every A entity is also included entity P. Like this. As the example, that employee is hourly M's and contract M's. So employees is cannot every employees can be hourly M's or contract M's. Is used to add a more specific description of the attributes in the subclass and identify entities that participate in a relation. And the fourth, aggregation is used when we need to model what is involved in a set of relations. This is the example. Like we have to related this entity to this aggregation. So this is called one entity and one, but the entity is a collection of many entities, like that. And now we will call relational model. What is it and how? Next, what is relational model? Relation itself consists of two parts. First is instance, a table with rows and columns. Rows is cardinality. Columns or fields are degree or arity. Scheme, determining the relation name plus the name and type of the column. Next, so how the relation model is? We have integrity constraint, condition that must be true. for an instance in database. Example, domain boundaries. And second, distance of a relation is legal if it can satisfy all integrity constraints that have been specified. And third, integrity constraints are also used to avoid the errors of data entry. What are they? So we will now see the example. So integrity constraint first is primary key constraint. What is it? As the set of the fields is a key of a relation if not two distinct tuples that have the same value for all key fields. K do not have a subset. If there is more than one key for a relation, then one of the key will be selected by the DBA to be the primary key. So there won't be two primary key. Primary key it's only contain one, and if there is two primary key in a relation, DBA will select who is the primary key in this table. Next, how? Still how? Second is foreign keys. Is a set of fields in one relation that use to conduct a reference to another tuple in the relation. So we can see the example in route in the table in route and student. So C have relation grade C have relation with the SID of student like B, E and P, and yes, it's called foreign key. So we can input the grade into the table using this SID. And the third, the last subject is structured query language. What is it and how? We will see. Next. So what is SQL? SQL is structured query language. Is a relational database language that made based on standard. So SQL used for the standard of database. The basic form of SQL is as follows. Select distinct is optional. Select list from list where qualification. Next, how is SQL? SQL provides three sets of construction. Manipulation, which expands the query. Basis, namely. So there are three sets of construction of manipulation: union, intersect, and except. It also provides another set of operations such as in. In is to check if the element has been defined on the set, any, and all to compare an element in the if score ID particular set. Axis to check whether a set is empty or the contents. In and axis operators can precede by not. So we can add not in, not axis like that. Next is another SQL feature is nested SQL query. It's meaning that the query has a query else in it, which is called a subquery. Nested query is used if there is an unknown value or unknown values. Example: select last name, salary from employees where salary is greater than. It's a query because we don't know how much the salary of employees where last name is John. So we use it and we compare to the main query. It's called subquery. Next, SQL supports 5 aggregate operations are applied to any column, namely count to calculate job, sum calculating the sum of all values, and AVG or average to calculate the average value, max seek the greatest value, and min look for the smallest value. Next is normalization. What is normalization? What is it? Normalization is the improvement of the database schema. Normalization need is for due to the storage of redundant information. So we can decrease the redundant information. What is redundant? That redundant is a column or a table that have many same data. So we can use normalization to decrease the amount of the redundant information. Next, example of normalization: 1F, 2NF, and 3NF. The difference lies in solving a table into 1, 2, or 3. So we divide from one table into 1 or into 2 or 3. Yeah, we have finished the theory, so we go to exercise. Let's do it. Question 1. Draw an AR diagram that reveals this information. First, Norton Record Company decided to keep all the information about the musician who worked on the album, as well as other company data in a database. Employers hire you as a database designer with a consulting fee of 2,500 per day, and two criteria: every musician who has a record in Norton SSN, name, address, and telephone number. The lower paid musician will get the same address with the other musician, and the address has a phone number. Each instrument used to record various songs in Norton have a name. Example: guitar, synthesizer, flute, and a musical key. Example: G, B flat, and E flat. Each album recorded in Norton have record title, copyright date, format, e.g. CD or MC, and album definition. Each song recorded at Norton have the title of and author the song. Each musician may play several instruments, and each instrument can be played by multiple musicians. Each album has songs on it, but no song appear together in the album. Each song by one or more musicians, and a musician could bring some of the songs. So with those many of criteria, we have to use the AR model. What's the answer? Here the answer. Sorry, I don't. So it's the AR model. Musician have SSN, name, address, number. Every musician have SSN, and yes, like that. And we know that it's a many relationship. Many to many, I mean, musician have many song, and many song played by musician. And so that with musician and instrument, it's a many to many relationship. Musician can play one instrument, or one instrument can play by musician or many musicians. Instruments have name and music. And the musician produce album. One musician can produce many album. And yes, so with it called one to many. And date. Album have attribute date, title, format. The format is CDM MC. And now we have album and song. It's also many to many relationship. Album, song release an album. And song have attribute title and composer. Here the answer. Have you got it? Next. Question 2. Question the following relational schema. We have the schema. Give an example of a foreign key constant that involves relation department. What are the options available for implementing this constraint when a user attempts to download a record in department? Musician will act as a producer. A musician may produce several albums. I'm sorry. It feels like I got the wrong. Yes. Here's the answer. We have 3 tables. We have the table. The example, the first table, second table, and third table. For the relational schema at number 2, define relation depth as SQL so that every department has a manager confirmed. Create table employees, MID integer not null, age in, debted, salary in, primary key, MID, foreign key, debted, reference department. For the relational schema number 2, write a SQL statement to display the employee who work in department IT. So the answer is it. We can select the ID, kemudian e-name, and then e-name from employees were debted sama dengan we use it as subquery because we don't know what is the someone who work in the name named IT. Okay, and next. For the relational schema at number 2, write a SQL statement to display the employees who work in department IT and have age more than the average age of the people who work in department IT. So we have to know the maximum average of age. So after it we can compare who is greater than who is smaller than average of age, where department ID is from select subquery like that. This is our end of first meeting. Thank you. See you at next PPT.